All right, so we are going to look at the second, strategy in solving systems, which is substitution. But first, let's just kind of review what we did in the last video, which was graphing systems. So let me go ahead and, whoa, sorry for that. Let me go ahead and zoom up. So the first thing I need to do is I need to solve these equations for y, meaning I want to get y by itself, so it's in slope-intercept form. So I'm just going to rewrite this guy over here. Now, if you notice, okay, I've got my x on the left and my y on the right. So what I would probably personally do is let's just add the y over. And then I'll go ahead and I'll subtract 3x. And so I get y, oops, drop my x, y equals negative 3x plus 11. All right, so I'll go ahead and I will plot that on my graph over here. Now, I go off the graph a little bit. That's okay. So let's see. So positive 11 is going to be 1 up here. Let's see. 1 up here. So I'm going to go down 3. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. All right. So I'll get one more point in there. So 1, 2, 3 over 1. Okay. So there's my first line, and then my second line, I'll have to, again, get y by itself. So I'll subtract x to both sides, and I get negative 2y is equal to negative x plus 6. Divide everything by negative 2, being sure to watch my signs, and I get y is equal to 1/2 x minus 3. So then I'm going to go back to my graph. It was minus 3, the y-intercept, and it was up 1 over 2. Up 1 and over 2. There we go. So I have a solution at the point for negative 1. Now let's say that didn't hit perfectly, okay? And it hit in between two points on a graph. So it was maybe like a decimal. We have to come up with kind of like a backup plan. Like, how am I going to solve a system if I don't have a graph, or graphing isn't my best option? So what I'm going to do is I'm just going to kind of get rid of my notes for a second, and I want to talk about something. You do not have to put this in your notes, so no need to put the following in notes for those of us that don't listen to the video. Okay, so let's say I had the equation 2x plus y is equal to 9. If I told you that x was 5, what would you do with that information? Okay, well, you would take that value for x and you would plug it in for x down here. And I would go ahead and do 2 times 5 plus y is equal to 9. And 2 times 5 is 10. And then I would obviously solve for y by subtracting 10. And I would get y is equal to negative 1. It's the same concept, except for here, what I'm going to do is I'm going to use, let's say, like an equation. So I'm actually just going to erase this really quick. Okay, so let's say instead of x plus 5, what if I said x was equal to 5y? Okay, I'm adding that in there. Same idea, I'm still going to take 5y and I'm going to plug it in for x because it's saying x is 5y. And by doing that, I've eliminated a variable and I can now solve for just y. So this would be 10y plus y is equal to 9. Combine like terms. Now I get a decimal in this example, but that's okay. And y is equal to 9 over 11. So let's kind of dive into our notes here. So what we do, here are the steps that we take. So when necessary, we solve an equation for one variable. Then we substitute the resulting expression from step 1 into the other equation. To replace the variable. Kind of like what you saw in that example down there. Then solve the equation. Step 3, substitute the value from step 2 into either equation. So at this point, you would know the value of a variable and solve for the other variable. And then write the solution as always as an ordered pair, because that's exactly what it is an ordered pair. So let's look at our first example here. Okay, so in number 1, it tells me what y is equal to. Okay, so y is equal to 4x plus 12. Okay, I'm going to plug that in for the y right below. So I'm going to remove it, and I'm going to rewrite my equation. So I do 2x plus, now I'm removing this y, and I'm going to replace it with negative 4x plus 12 is equal to 2. Okay, now in this case, I can actually write it without the parentheses. It's like distributing a 1. Okay, combine like terms, I get negative 2x plus 12 is equal to 2. I'm going to go ahead and subtract 12 to both sides. I get negative 2x is equal to negative 10. Then I'll divide by negative 2, and I get a value of x at positive 5. So now all I have to do is take that 5 and I'll plug it in. I can technically plug it into either equation, but the top one looks like the easiest. So it says y is equal to negative 4 times 5 plus 12. Well, that's negative 20 plus 12, and so my answer comes out to be negative 8. So my answer, always as an ordered pair, is 5, negative 8. Let's look at example number 2. So now in this one, this is a great example where I don't have a variable by itself. I do not have a y equals or an x equals. I need to have one of those. So what I need to do is I'm going to manipulate an equation to get x or y by itself, and just looking this over, look how easy it would be to get x by itself. All I would have to do is add 2y to both sides, right? And so now I have the equation y is equal to 2y minus 3. And what I like to do is just cross this equation off. I'm no longer using it, so I don't want to get confused. So now I know what x is equal to. So x is equal to 2y minus 3. Okay, that kind of backfired. That's kind of hard to see through. Sorry. And then we're gonna plug it in for that x right here. So I'm going to rewrite this equation, but I'm not going to write x. Instead, I'm going to do 3 times whatever x is, which is 2y minus 3, plus 5y is equal to 24. So now I distribute my 3, and I get 6y minus 9 plus 5y is equal to 24. Combine like terms to get 11y. Then I'll go ahead and I'll add 9 to both sides. And I get 11y is equal to 35. I feel like I made a mistake here. Oh, that's because it's not 35. Just kidding. It's 33. So 33, and then I can divide by 11, and y is equal to 3. Okay, so if I know my value for y, I can just bring this back up here and I can plug it into any of those 3 technically equations. But this guy looks like it would be the easiest, right? So it would just be x is equal to 2 times 3 minus 3. So 6 minus 3. So your value for x is then also 3. And so your answer as an ordered pair is 3, 3. Let's look at some more examples. So in number 3, okay, what would be really easy to get by itself? The x. So I'll add 2y to both sides. And so I get x is equal to 2y plus 9. So now I can see that, let me get a good highlighter here. So x is equal to 2y plus 9. So I'm going to substitute it in for that x. And remember, I'm going to cross this equation out right here. Okay, I'm not using it. So I do negative 7 times 2y plus 9 plus 7y is equal to negative 14. And we'll distribute the negative 7 to get negative 14y minus 63 plus 7y is equal to negative 14. Combine my like terms to get negative 7y minus 63 is equal to negative 14. Now let's see, we'll go ahead and add 63 to both sides. So adding 63, and I get negative 7y is equal to 49. Divide by negative 7, and so we get y is equal to negative 7. So if I know y is negative 7, take that information, let's bring it back up to the top, plug it into any equation. This looks like it's going to be the easiest though. So I would do x equals 2 times negative 7 plus 9. Well, that's just equivalent to negative 14 plus 9, and so your answer for x is going to be 5, negative 5. And so my answer then is negative 5 comma negative 7. Let's look at number 4. So in number 4, I'm looking for the easiest variable to get by itself. Look how y has no coefficient. Now, I want to point out, it's not always going to be the top equation that we're going to manipulate. It just happens to be that way. So I subtract the 7x to the other side, and I'll get y is equal to negative 7x minus 2. So I kind of just cross that out. I'm not going to use that anymore. And so I'm going to take my value for y, and I'm going to plug it in for the other equation's y. So I rewrite that equation as negative 6x minus 2. Now y would naturally come next, but instead I'm going to put in its value, which was negative 7x minus 2. Now I'm going to distribute a negative 2, so always be careful of your signs. That's going to change this to positive 14x and positive 4. Then I can go ahead and combine like terms. That's going to give me 8x plus 4 is equal to negative 4. I would subtract 4 to both sides and get 8x, is equal to negative 8, and divide by 8, and we get x is equal to negative 1. So now, if I know what x is, I'm going to take that information, bring it back up to the top, plug it into the easiest equation to solve for x. I'd probably say it's that one. So I would do negative 7 times negative 1 minus 2. So that's just 7 minus 2, so y has a value of 5. And so my final answer is negative 1 and 5. So if you're feeling kind of confident, try number 5 on your own. Otherwise, just follow along with me. So here's an example where I'm not going to manipulate the top equation. I'm going to manipulate the bottom one. And look how easy it would be to get x by itself here. So I subtract 5y. And so I get x is equal to negative 5y plus 20. And let's go ahead and kind of cross out this equation. I'm not going to use it anymore. And I'm going to take this negative 5y plus 20, and I'm going to plug it in for x, because that's what it equals. So I'll do 2 times negative 5y plus 20 plus 10y is equal to 40. And I distribute the 2, so I get negative 10y plus 40 plus 10y is equal to 40. And something interesting happens when I combine my like terms. They cancel out, and I get 40 equals 40. And hopefully, if you remember this, you should. From Unit 2, this is a true statement. Yeah, 40 equals 40. So we say infinite solutions. Infinite solutions. S. All right, last one, number 6. Okay, let's think about which one's easiest to get by itself. That y has no coefficient, so I subtract 3x to both sides. And now I have the equation y equals negative 3x minus 3. So I'm going to kind of cross this out. Not going to use it. Don't want to get confused. So I'm going to take that value for y. Let's plug it in for that y up top. So I get 6x plus 2 times negative 3x minus 3 is equal to negative 8. We'll distribute the 2. And then I'll combine like terms, and I notice that they cancel. This is not true, what's left over, and we call that no solution. Hopefully this is ringing a bell. All right, so get used to word problems in this unit, because we're going to do a lot of them. So we're just going to kind of like, squeeze one in every video. So in this one, it says a nature center charges $35.25 for a yearly membership. So there's one option. Or $6.25 for a single admission. Last week, it sold a combined total of 50 yearly memberships and single. So altogether it was 50. And they gathered that much money. So how many memberships were sold and how many single admissions were sold? So what they're asking me, memberships and single admissions, those are my unknowns. All right, so those are my variables x and y. So I'm going to say x is equal to memberships, and y represents just single admission. Remember, it's important that we define our variables. From this, I can now write my equation. So they tell me that altogether I sold 50 of them, right? So however many memberships plus however many single admissions should equal $50. Or I'm sorry, 50 that I sold. Now let's include their cost. So up here it says the yearly membership's $35.25. So we'll do $35.25x plus then the single admission is $6.25 is equal to, well, how much money did they gather, which was $660.50. So those two bits of information are what make up my system. And so now I can go ahead and I can solve. I'm going to get, I know a lot of you guys probably like to get the y by itself, so I'll go ahead and get that by itself by subtracting x. And so I get y is equal to negative x plus 50. And I'm just going to lightly cross this out, not going to use it. So this now goes in for this y up here. So I'm going to do 3525x plus 625 times negative x plus 50 is equal to 660.50. And then I'll distribute, and I get 625. Ooh, I'm sorry, I made a mistake there, watching my signs. That should be negative 625x plus 312.5 is equal to 660.5. And don't worry, I haven't forgotten about the 35.25x. I'm going to bring that down. I'll go ahead and combine like terms. And that's going to give me nicely 29x plus 312.5 is equal to 660.5. And then I'll subtract 312.5 to both sides. And I get 29x is equal to 348. And finally, divide everything by 29, and I get a value of x being 12. So that means that there were 12 memberships sold. So now let's take this information, guys. Let's take this. Let's bring it back to that original equation that I made. Okay, if I know that there's 50 altogether sold, 12 of which were memberships, okay, I'm going to take the 50, take away 12, and that's going to give me y, right? So that would give me a y value then of 38, single and membership. All right. So at this time, try these three on your own and check back in to see if you've done them correctly. Okay, so in number 1, they so nicely got y by itself for you. So you're going to plug it in for this y down here. Now, the most important thing is that you have to use parentheses because you will have to distribute a negative. So I get 4x minus 3x minus 1 is equal to 2. And then when we combine like terms, we get x minus 1 is equal to 2. Add 1 to the other side, and x is then 3. When you plug that into that top equation, you get a y value then of 7. So your final answer is 37. Now, number 2, you will get a decimal, so don't panic. All right. So I would probably get that x by itself. It's going to require 2 steps, but it's going to be the easiest. So I would subtract 4y to both sides, and I get negative x is equal to negative 4y plus 16. Then divide everything by negative 1, and get x is equal to 4y minus 16. So I'm going to kind of cross that out, not going to use it. Don't want to get confused. I'm going to take that, plug it in for that x up there. So I'll do 3 and take out the x, put in 4y minus 16. Minus 6y is equal to 9. Distribute the 3. Combine like terms, so I get 6y minus 48 is equal to 9. Add 48 to both sides, and I get 6y is equal to 57. And divide by 6. And y is equal to 9.5. And if you read the directions, you only had to find the y value. So, oh, that looks like 95. It's 9.5. And then finally, the word problem. Hopefully you attempted this. So it says a store sold a total of 125 car stereo systems. So I'm going to underline that. That looks important. And speakers. So it's together. So those are probably my two unknowns. The stereo systems sold for this much money. And the speakers were this much. Altogether, they gathered that much money. How many stereos and speakers were sold, and how much would it cost to buy 2 speakers? Okay, so first of all, let's define our variables. So we'll say X is a car stereo, and Y will be the car speakers. I just spelled stereo wrong, sorry. Speakers. So it said all together, they sold 125 pieces, right, or units. Then it goes on to tell me how much they cost. So $104.95 for the stereos plus $18.95 for the speakers is equal to $6,926.75. So there's my system. So the next thing I would do is I would get personally this Y by itself. So I would subtract X, and I get Y is equal to negative X plus 125. So I take that, we're going to take that and plug it in for that Y here. So I'd have 104.95X plus 18.95 times negative X plus, let's see, is it 125? Yep. Is equal to 6,926.75. Some big numbers here. I'll distribute the 18.95. And let's see, that's going to give me, obviously, negative 18.95x. I didn't calculate this one. Let's see. So 18.95 times 125 is 2,368.75. And, of course, bring down the 104.95x is equal to 6,926.75. Let's combine these like terms. So 104.95 minus 18.95 is going to give me a nice number of 86. I'll bring everything else down. It's equal to 6,926.75. We'll subtract this over. This cancels. Subtract it over here as well. Let's see. So we got 6,926.75 minus 2,368.75. Oh, that doesn't look right. Let's try that again. 6,926 minus 2,368. There we go. So I'm left with 86x is equal to 4,558. Oh my goodness gracious, I divide by 86 and I get 53. That means they sold 53. And then I want to know how many did they sell for, and that's 53 stereos. And if they did 125 in total, we'll subtract 53 from that, and that gives me 72 speakers.